with another edition of Tech Talk with Ray and Mike. How you doing, Ray?
Hello, Mike.
It's a good day in Colorado Springs,
yes.
isn't it? Base
Nice
of Pikes
summer day.
Peak. It's warm.
Yeah.
We're in Cherrywood Studios. It's a good thing.
Yeah.
We have a great show lined up today. Pretty excited. Today's all about robots.
Yeah, robotics.
That's going to be fun. So I don't know a whole lot about robots.
Okay.
But I know you're going to teach me, so this is a good
little
thing.
bit, sure.
So let's start off with a simple question.
All right.
What's a robot?
Well, there's a lot of definitions. There's a lot of things you can do with a robot.
Okay, how do I get started?
I think the simplest reason to have a robot, the simplest robot,
To scratch my back?
is not to vacuum your floor, not to clean your dishes,
I'm out.
to just communicate. That's it. There's a lot of people, elderly people, single people who would just like another member of the family. Imagine if you had a robot that just kind of walked around the house.
It was just a presence.
It was, and you could walk over, you could ask it a question. It would always know the answer. Or it would say, hey, I'll go look that up. And it would come back. You would have conversations, long-term conversations, ongoing conversations that you could just kind of ask, and you had a relationship. It would build a relationship because it knew your history, and you could ask questions, and you could get answers, and it was just kind of a companion. That, I think, is the most compelling reason for a robot.
And see, that would scare me.
Not to clean the floor. Anyway, so
it's like a pet.
Well, a little bit. Yeah, sure. Right.
A pet that knows you.
Yeah, it doesn't have to look human, but anyway, that's my idea. That's what I've always thought would be the most compelling reason to have a robot.
Do you think that's where it's going?
Well, sure. Yeah, I think that with access to the internet, you can almost do that with Google now. You can go ask it just about any question. It'll come back, and Google lady will tell you the answer. Siri.
Right.
And
is that her name Google lady? Or is that just what you call her?
That's what I call her.
I think that should be her official name, Google lady.
Yeah. Yeah. So.
Okay, so how do I get started with robots? I mean, you have to start somewhere. I know nothing.
Well,
about robots.
Do you want to buy a robot or do you want to build a robot?
I want to build a robot.
Okay. So you want to build a robot.
Yeah.
And you want to know how to get started building one.
Yeah.
Okay. I would say get started with the Arduino. Have you heard of an Arduino?
No.
All right. It's a nice, simple starting place. And if you go out to arduino.cc, that's a strange URL, but if you go out to arduino.cc, you will see, you can learn all about this little Arduino. The Arduino is not a robot. It's just the brains. Okay? So picture a little, 3-inch square motherboard. Okay? It's very small.
Okay.
On that motherboard, you have a little microprocessor. There's a couple of K of RAM. Okay? So it's not a really big power plant. It's not a big motherboard. It's not a laptop. It's just a little microcontroller. Okay. So on that microcontroller, you're going to get some digital input and output pins. I think you get about 14 of those on the very basic board. Okay. I think they're only like $25-$30. Okay.
Oh, okay.
You go out,
That's
you get one. For the longest time, they were manufactured in Italy. Now, I don't know if that's still the case. There was some copyright issues. There was some problems with the company and shareholders fighting and so on. But you bought them. They came from Italy. Okay. Anyway, little 3-inch square board, and it gave you some digital I/O. You could use just to turn lights on and off. This is very basic stuff. You had 6 analog inputs, so you could get input from joysticks, switches, sensors, things like that. Wow. So you start to get the makings of a little brain that you could connect up and make your own little robot.
How cool is that?
There's a USB connector on it, and you basically will download code that you write. So you can write software. They give you a little development environment, a little studio that you put on your laptop or whatever. Plug in your USB connector and over to the Arduino. You write your code and download it right down to the device. So now the code's on the device, and you can just run it. So when you run your code, you get to take input from these little switches, potentiometers, sensors, things like that, joysticks, and you can start making your own little robot that kind of senses its environment and sees things and provides some then output on those other digital I/O pins.
Okay, so I have a question, and this isn't along the lines of robots, but how would I make the Arduino turn on and off lights? I mean, would I have to be at a computer to do that, or is it like a timer?
Well, it's actual software code. Okay. So they give you some example code to learn how to do this. But basically, you would be writing software programs that output signals onto the I/O pins. You have a digitalWrite. You have a digitalRead. Okay, those are functions that you can include in your program that would turn on an I/O pin, an input-output pin, and you have a digital read that can read the status on that pin. Okay. So what I mean by pin is there is an actual little copper wire that's coming out of this thing, and you hook it to whatever you want to hook it to. So you hook it to an LED. You can hook it to a switch, those sorts of things. Now we're talking the very, very basic levels here.
Right.
How to get the very basic input and output from the device. But you're going to write code in order to do this. It's not a timer. It's not built in. You have to do all of that yourself. If you want the light to turn on and off every second, you have to write some code that has a loop. Okay? Starts at the top of the loop, goes down, turns the light on, comes back up the other side of the loop, turns the light off. That would blink. Okay. So you could have a light that blinked. So
programming-wise, what would I use?
You would use a language called C++.
Okay.
And C++ was invented, back in the 60s? I don't know. AT&T invented it for their telephone switches. Bell Labs. And they invented it long, long before I was born. Anyway, they invented C++. It's been around for a long time, and a lot of programmers use it. So you can write C++ or C, and you're basically getting the full C language. You're getting control structures, arithmetic, so you can add, subtract, multiply, divide, all of the things you need to do to compute things inside of this little microcontroller brain. And you get comparisons to compare one value to another. If you're taking input from a sensor or something, you're watching for a certain voltage. You can look for, let's say, 1.2 volts, and when you see that, I know that it's just saw something. Depending on the sensor that you have those kinds of comparisons. There are variables, math functions, data types, all sorts of data types, integers, floating point, decimal, strings, characters.
So being so basic, it's really not, right? As far as you said, it's like basic programming, but that sounds way more than just basic.
I know,
and
it
I'm
does
not
sound
a coder,
that way, right?
But there are probably some coders out there saying, "Mike, you don't know what you're talking about."
Well,
that's true.
No, you're right. It is not basic. You will spend some time learning this. A typical coder goes to school. Bachelor's degree takes you 4 years. It takes a while to come up to speed. And for me, I jump right in there, bits and bytes. I just know all that stuff just by nature. I've been doing it for 100 years, and it's just so easy.
So it's easy.
But it does take some time to come up to speed and to learn those things, learn the concepts of software development.
Okay, so you say it's a little square motherboard. Is that all it is?
Not really. There's a little more to it. And wait till you find...
It sounds like it.
Yeah, wait till you hear what's involved. And that's why I say you could use it to make a robot. It turns out that there's a little on the board. There are some rows of pins. Okay. Mm-hmm. So you have to just imagine these little metal studs coming up. There's a whole row of them on one side and another row on the other side. Okay. And they're intended to allow the internals of the board, of the motherboard, to be exposed to another board that would snap on top of it.
Okay.
And those boards are called shields. I have no idea why. I mean, that's a crazy term. That's what they came up with. They probably have a reason for it.
Right.
In the old days, we used to call them daughter boards because you had the motherboard, right? And another little board on top of it would be like a daughter board.
Okay.
I don't know. That's what we used to call them. It's probably the same term, but these people are calling them shields. Okay. And basically what they are is little boards about the same size.
Okay.
And they do actually shield the motherboard. You can't see the motherboard. Once you snap it on, it covers up the motherboard. Okay. I mean, you got a picture of this little 3-inch square. That's all it is, a tiny little microcontroller board. We think of motherboards as big.
Right. What's in your computer?
Right. 8-inch square, big thing with a lot of chips on it. This just has a few. There's not much on there.
Okay.
It's all built into this little microcontroller.
Okay.
And so you snap on these little daughter boards. They kind of piggyback on top with those rows of pins. So all the power goes up to them. All of the data buses, the address buses, all of the information that you get for programming, you could put another Arduino on top. And
so you can daisy chain them.
Yeah, you stack these up. Okay.
Very cool. Okay.
So this thing now becomes a little cube. Okay, so it starts out as a little flat 3-inch square thing. But as you add these shields, it grows taller. And you end up with this little cube, a little square.
And it's more powerful, I'm assuming.
Because those little shields have a lot of little purposes. And you can go out to the arduino.cc website and see them all. But it turns out there's like 550 of them right now as of this podcast. By the time you guys hear it out there, I'm sure there'll be 600 of them. I mean, these things multiply because everyone's into this. This is the hobbyist thing. I mean, it is a fun thing to do. From starting at age 10 to, age 50. It is fun to play with these things.
I'm going to have to try that out.
They really are a lot of fun.
So for people like me who don't really know coding, or I've learned to not like it because I've attempted it and forget that I'm a creative guy, is there any help online that tutorials or whatever?
Right. There is a lot. It turns out there's so much that you can do with this that there's a whole community that has built up around it. And so everyone who jumps into this wants to invent something new. It's a whole community of little newbie inventors.
How cool is that?
They have invented motor controllers. So you talk about a robot, you want to control some big motors. What you do is you get these stepper motor controllers.
Okay.
That basically control motors so your little robot can run around. A stepper motor is basically just a motor that steps in jerks. It's like they're tiny little steps. Beep, 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 beep. The wheel is turning in very precise amounts. So it can turn in 1 degree increments. So instead of turning all 360 degrees to go a full circle, it can turn in 1 degree.
Okay.
And so you have very precise control over the motors. That's a stepper motor.
Cool. Okay.
You can buy these stepper motors. You buy stepper motor controllers. A lot of those out there because everyone wants to build a robot.
Right.
That's the first thing. So you got stepper motors. You got storage for SD cards. You can plug little micro SD cards in. This thing can read SD cards. Huh. You have to download a special library and put that into your RAM.
Right.
But that allows you to read those. You can have other shields that have more inputs. other kinds of sensors. You have accelerometers, rangefinders, ultrasonic rangefinders, so your robot can look out and see walls, see obstacles, things like that, see stairs, avoid those kinds of things. You've got gyroscopes, GPS, Wi-Fi, Bluetooth, infrared. I mean, there's just all kinds of these. You wait till you see it. You go out there and you will be shocked at this stuff you see out there.
Do people share code? I'm assuming they do.
Yes, there is, like I said, this whole community, and you have people asking questions. You have other people who have figured out the answers, who are contributing answers. Mm-hmm. You have, these, super contributors who are just out there with every answer you want, and everything you can imagine out there. There's barcode reader inputs. So you can read status of barcodes, like at Walmart, beep, beep, read the barcodes.
So how would that work with standard time then? Because I know that we're powered by standard time. And so how would this work with the barcodes? Because we have a scanner option within standard time to start and stop timers.
Right. So for the benefit of listeners, Mike's talking about the feature in standard time timesheets that is a barcode input, and you can start and stop a timer, get timestamps to usually use for manufacturing. And a lot of times these Arduinos are used in manufacturing, and used to control little things, to control little motors, or to take input from sensors or things like that out on the shop floor. Mm-hmm. But no connection. Standard time does not run on Arduino. Even though you have these barcode reader inputs that you can read a barcode, they are probably not using that for collecting employee time, manufacturing time, any of the things like that. So if you want that kind of stuff, you got to go to a bigger app, and that's what standard time is.
And it's also a free download.
It is.
The iTunes Store, Google Play, and stdtime.com, which is the website for Standard Time.
Right.
Little plug there for Standard Time. It's a good program.
Yeah.
You also get a free trial period for the desktop software, which is awesome.
Yep.
It's great stuff.
So, but you're right. The iPhone, the iOS, the Android versions are free, completely free. There's no nags. There's no pop-ups, no advertising. No expiration. It just keeps running and running, and you could use it forever.
That's a sweet app too.
Standard time's cool.
So back to the
Arduino.
Arduino. Right. Sorry, I digress.
Right.
I like to say derailed.
Derailed.
But not really.
Not quite derailed yet.
So the Arduino. Now I have kids. Should I get them into this?
Absolutely. Obviously, your kids, right?
Right.
And you try a lot of things. When I had kids, we tried a lot of things out. Mm-hmm. We'd offer this, life experience, or say, would you be interested in this kind of occupation?
Right.
And I got to tell you that engineering, the things that you do with these little Arduinos, is a pretty tedious kind of work.
Is it?
And yes. And you have to have you have to be the right kind of person that likes to just sit there and just tweak away at electronics. And this is the kind of stuff, they're going to learn electronics, programming, engineering. All of that stuff is just very detailed and tedious. For the average person, they look at that and just say,
no, thank you.
No. And I mean, they're happy to, turn their laptop on. They have no idea what's inside there.
Right.
I mean, if they were to take it apart, which they can't, most people cannot even take a laptop apart. Right. And they're pretty darn hard to get apart.
Yeah, especially the Macs.
But you look inside of them, it's like, what on earth is that? Right. They have zero understanding of anything inside there.
Right.
That's the world that we're talking about. That's the world that if you get your kids into this, they're getting into extreme geekism. I'm telling you, they're going to turn out just, tape on the glasses, pocket protector, weirdos.
Weird. Nice.
It used to be, I think until the 80s. Bill Gates changed all this, but it was in the 80s, 70s and 80s. If you were a geek, if you were electronics or software, it's like, ooh.
If you liked Radio Shack.
Yeah, you were like this kid that got kicked around,
Right.
But then Bill Gates became like this rock star. Now everyone wanted to do it. So in the late 80s and 90s, everyone wanted to get into computers and stuff. So, it's kind of a cultural thing. Not all cultures have it.
Right.
Not all countries have it. In the U.S., most Western countries, it is fun to get into this kind of stuff, into the bits and bytes and details and, binary and hexadecimal and all this kind of weird stuff, and just, learn how to program computers. So if your kids have that kind of aptitude where they like the detail, they like the geeky stuff, yeah, I think it's really good.
And it's a relatively cheap startup too.
Yeah.
It's like if they're not interested, you're not out, new guitar or a piano.
Yeah, right.
It's a $40 computer chip ultimately,
exactly.
Motherboard.
But you watch, once they get into it, it rolls up into the hundreds because they'll be buying all these little shields to plug it. Dad, I want this.
I need the wheel to only move 1 degree.
Yeah, so the kind of weird things that they're going to start asking about, what can I build with it?
Right.
And they're going to want to build some stuff. And once they start getting into this, you find out you can build things like a drone. Okay, so you talked about, can I build a robot? How much does it take to build a robot? Well, there's other cool things to build.
Yeah, what can you build, or what have you seen built?
Well,
and I'm assuming your imagination is
the limit, right? Yeah.
So
drones are a wonderful thing,
yes,
because they got the 4 little blades sitting on a platform, and it has to be very light, and so you can put an Arduino on there and a 9-volt battery to power it. And it turns out they've got the motor controller, shield. They've got the self-leveling thing so that this thing doesn't, flop over.
Right.
They got the whole drone controlling software that you can download these libraries and put it into the Arduino's RAM. And that's going to control the 4 different blades, because they turn at different speeds, and they have to kind of level and move around for navigation and so on.
Right.
All of that stuff can be downloaded. That's a fun project. It'll be a great project.
Fun project.
One of the things I built back in the olden days was an oscilloscope.
What's an oscilloscope?
Oh gosh, this is where it gets pretty geeky. An oscilloscope nowadays is done on a laptop. In the olden days, Tektronix, HP had these things called oscilloscopes that you would buy. I'm really dating myself. That had a screen, had a phosphorus screen, and it had a trace going from left to right.
Okay.
And it was measured in time, left to right. And then as a voltage came in on the probe, it would bloop. You'd see it on the screen. Okay. So repeating voltages, like let's say a 60 cycle electrical outlet. You plug it into the electrical outlet, and you see a sinusoidal wave. Okay. And so you can look at waveforms. You can look at antenna input. You can look at audio, analog type things.
That's
you
cool.
Simply take your probe and you probe around on a device. On computers, you can see repeating waveforms on the oscilloscope. So anyone who's in electronics has to have an oscilloscope. So if you get into electronics, which is more than software, you're getting now into the electrical components, soldering up your own circuit boards. These are things that kids can do,
right?
And you can create little electronics projects, and you need an oscilloscope to be able to probe them and to see what is on these electrical pins. And so you can build a little input into your laptop and use your laptop then as an oscilloscope. So that's awesome. I built one myself.
Do you still have it?
No. It was just built, and I thought, oh, this is cool. And then I threw it away. because I had a big $10,000
oscilloscope.
Tektronix, quad input Tektronix.
So you built it just to
say that I was able to do it. You understand the concepts and stuff like that. It was early on in my hobbyist career. Right. I built a robot in high school. I don't know if I told you that.
No.
Yeah, I did.
Tell me.
Oh gosh. See, when did Star Wars come out? 76?
77.
77.
Yeah.
Okay. When R2-D2 came out and C-3PO, every electronic geek wanted to build one.
Right.
I guarantee it.
For good reasons.
And I was in high school at the time, and I wanted my own.
You really just dated yourself.
Oh, no. I wanted my own C-3PO, R2-D2. So I built it. I cut a little piece of wood out, and I put some. They didn't have good stepper motors, or they did, but they were $1,000 a piece. I had these cheap analog motors, electric motors I put on it, and mine was built without any. I had no microcontroller. It was all discrete electronics. But it would control the motors and move it around, and had an umbilical cord with a little set of switches, and I would and make it go and make it go around.
That's awesome.
So yeah, that was I'm telling you, every kid wants to build a robot,
right? And
you get your kids into this, they're going to want to do that. That's a pretty big step. So you might want to jump into some other things that you could do. You could make a little trip computer with GPS, because they have a GPS shield. So that has a GPS radio, receives the GPS signal from the satellites, and will give you your GPS position. So you could have a little trip computer that says, okay, we drove 500 miles, and type in how many gallons of gas you bought, and it could tell you what your gas mileage is, things like that. That's a fun little project.
Right.
So there's just so many different things that you can do and to play with and to spark your imagination. It's a fun little thing.
Yeah, that's I'm actually interested in buying it. One, to see if my kids are interested in it.
Right.
But two, maybe to see if they would want to build a drone with me or whatever.
Yeah, right.
Because I'm all for finding the code that's already made and just pumping it in there and then just building the thing ready to go. And now, how would do they sell the remote control thing that you can control? If I were to build a drone, you need
radio.
something. Yeah, the radio to actually control it.
I don't
something
know.
I'd have to buy Radio Shack.
I think you can, because I'll tell you what else they have. They have Bluetooth and wireless shields.
Oh, wow. Oh, so you can control it on your smartphone.
Yeah, exactly. So you could get a little, Bluetooth connection directly to your iPhone. And as long as it doesn't go out of range.
Because then it just takes off and never comes back.
Or maybe it just goes dead. I don't know.
Right.
But or maybe it refuses to go out. You could program it to refuse to go out of range. As you got GPS. I know that I'm 200 feet away. I'm going to lose my Bluetooth connection. I'm going to stay right there. Yeah, I won't allow myself to go out farther. So that's an option. That's just a hobbyist thing.
Right. You don't see. I'm interested. I had no idea this existed, and now you may have just made me a computer geek. Thanks, Ray. Right.
So remember in the old days, it used to go down to Radio Shack and buy those, 50-in-1, 75-in-1, 100-in-1 electronic kits, and they had the resistor, the diodes, the transistors. They had an integrated circuit. Ooh, wow! You could plug little wires in and turn on lights and stuff. That's exactly what this is. It appeals to that same kind of interest that young little geeks
and
want to get into.
I think my 5-year-old son, would be totally into this. Yeah. Because he has his hands in everything. And we just went to Goodwill and bought him a keyboard and gave it to him and said, here's a screwdriver. And I mean, he played with that thing.
Seriously, he took it apart?
Took it apart, looking at all the controller boards and buttons. And I mean, he destroyed the thing.
Why not?
But
$5?
$5, and he was for at least 3 weeks.
Yeah.
He was just playing with his keyboard, just taking it apart. Because what he did is, before we did that, he would take the screwdriver and unscrew all the light panels that cover up all the wires, which I don't care, but there were live wires back there.
Yes, right.
Or he'd take out all of the doorknobs, take the screws out and then just leave it. So we're like, we need to do something with you. But this may be something he's interested in.
Henry Ford was the same way. He would just take stuff apart. And he was one of the few that could get it back together again.
Wow.
So,
well, hey, maybe my son's the next Henry Ford.
Yeah, who knows?
So just need to support that.
Now, if you have daughters,
I do.
They may or may not have interest. Now, I don't understand this, and maybe it's a segment we need to do, but why are boys, and turning into men, more interested in engineering, electronics, software than girls? It turns out that the engineering schools right now, there's only 19% women.
Really?
Yeah.
Huh.
And I remember, this is so funny, when I first got into my first engineering job, I don't know why, but I just expected all men, right?
Mm-hmm.
And I saw my first female programmer. And I was like,
girls do this.
Girls, I just stood there and stared at her because she was talking about software. I wasn't in love or anything, but I was just standing there going, what is she doing here?
Threw you for a loop.
Yeah, because back in the 80s, 90s, it was like 5%. And now there's more and more women getting into it. But back then it was an oddity. It was a rarity to see women especially in software. I just remember looking at this lady, this girl, and she was a competent person. And she was going on about how
she knew what she was talking about.
Yeah, written all this software. So I said, how do you do that? Women can't do that. That was so stupid.
That's awesome.
Oh, gosh.
Well, this has been a great show. Thanks for bringing this topic, because like I said, as far as robots go, it was all 80s tech for me.
Yeah.
Or like Robot Wars.
Right.
On TV, which I love Robot Wars. I don't think they played anymore, but and who knows? Maybe that's how they built the robots with it.
It could be. You're right. Little microcontroller.
Yeah.
Right.
But that's good stuff. That's really good stuff.
Cool.
Remember, subscribe to the podcast. Leave comments.
Yeah, some comments.
We're on iTunes. We're on Google Play. Of course, if you've downloaded this, you probably already know that. But you can download it at the website at stdtime.com. With Standard Time, download your free apps. They're great things, but most importantly, we want to hear back from you. So remember to subscribe, leave comments. If they're bad ones, direct them towards Ray. If they're good ones, direct them towards me, and everything will be fine. So that's our episode for today.
Yeah.
So that was fun. Thanks, Ray. And we'll see you next time. Next time, we are talking about what, Ray?
Well, I thought we might get into 3D printers. What do you think?
I think that sounds wonderful.
Yeah?
That's the next big thing.
Yeah, sure.
Yeah,
sure is.
Totally. So tune in next time. We're talking 3D printing, and we'll see you soon. Adios.